Greetings and welcome, friends. Mr. Wada here. We're in section 5.6. You are in for a treat today. You are getting not one, but two congruence theorems in this one video. It's going to be amazing, amazing. One of them is presently on the screen. It's called the angle side angle congruence theorem, which says the following. If two angles and the included side, oh man, that's why I don't draw with a mouse. I use my writing tablet. Included side of one triangle are congruent to two angles, and the included side of a second triangle, then the triangles are congruent. So what do we mean by included side? The side that touches both of the angles. All right, the side that touches both of the angles. All right, here I've got a little geometer sketchpad sketch for us, where notice that, so here I have a side, CG, that is a fixed length. And I can change the dimensions of these angles, right? And no matter which way I put it, there's only one possible intersection between those two sides, right? Here I have these rays that are traveling off of it because, right, I wouldn't know the length of these sides. I just know angle, side, and angle. Yet there's only one triangle that will ever form no matter how I set this up. Will it go obtuse for me? Yeah, it does. And then if then it's just like not even a triangle anymore. Whoa, that's craziness. But yeah, so angle side, angle, two angles and their included side will result in just one triangle possible. All right, so that's what this theorem suggests. I'm not going to walk through the translation rotation proof, but you can see that in your Libro, or part of it. I just gave you the start of it on your packet, maybe. Actually, I don't even remember what I did. Either way, I'm sure I agree with my past self to some degree. Now check this out. Wow, if you were worried about those other sides not feeling included, guess what? You're in for a treat. Wow. Angle, angle, side. If two angles and a non-included side of one triangle are congruent to two angles in the corresponding non-included side of a second triangle, then the two triangles are congruent. So notice as I travel around my shape here, angle, angle, side, right? Like that's how I see it. Angle, angle, side. You could also argue that side, angle, angle would work, but it's just a reflection of the same thing. Question, comment? Oh, like why didn't they somehow simplify into just like, hey, if you have two angles and a side, then triangles are congruent? I see the power of that. It's maybe a good idea to think about that. However, they are proved differently, and so I think that's why they had to be discovered separately. Let me show some angle side situation here. So this one's a little bit more of a complicated sketch. So I've got an angle, all right? I've got another angle, and I've got a side length like so, all right? So the side length, you could imagine this blue side can swing, it can hinge around and land wherever I want. But as far as the number of locations that this is actually going to be a triangle, right? So those two angles are fixed. There's only one possible spot where a triangle is formed. One single triangle, all right? One single triangle, right? We'll make one other variation on it. Let's see. Even if I do that, right? There's only one way that, oh, that's not a triangle. Now it's a triangle, all right? In order for this angle to be fixed, this angle to be fixed, right? There's only one way that it works. Only one way that it works, right? So you can kind of see that angle, angle, side, there's only one triangle that can be formed, right? If I wanted to snap it on that point, that would have changed this angle down here, and so that wouldn't work out. All right, so you can kind of see the visual as to how that might make sense. And yeah, so these are very similar. They've got two angles and a side, and yeah, we'll just say yeah. So let's jump right into example one. Ooh, we've got some pictures from real life. Actually, I was at a wedding at, I forget which mountain it was, in New Hampshire this summer. And there was just some beautiful architecture of like this giant hexagonal building and all sorts of lumber beams intersecting. And I was tempted to just be like taking pictures of all like the beams because, man, those angles, my friends. There was just so many congruent triangles, and it was a beautiful wedding because of the congruent triangles. Wow. I didn't want to creep people out. Like, what's he doing? Why is he taking pictures all the wrong way? Let's see. So it says, can the triangles be proven congruent with the information in the diagram? Okay, so here we got, it might be hard to see these triangles, but it's talking about these guys right there, right? I know that these two angles are congruent. I was told that these two sides are congruent. Now, I don't know about these sides, okay? I don't know, right? This building could somehow just get like wider or something. I don't know. I don't know what's happening. But what else could I prove? Vertical angles theorem. Horizontal angles theorem, more like it. Hats off to you, my friend. Oh, man. Wow, classic. So anyways, vertical angles theorem. Now I could prove those triangles congruent using which theorem? Angle side, because this side is not the included one. It's not in between the angles. So angle side. All right, here we go. You're out on the beach. You've got your umbrella. You're in the shade because everyone hates the sun. Maybe. I do. I also hate the sand. Why do I go to the beach, guys? Man, I just don't. Yeah, sorry. Not a fan of the beach. But here we go. I've got some angles going on. I've got some more angles here. This looks like angle, which does not exist. There is the angle similarity theorem. So I know that these triangles are similar but not congruent. So no, not enough information. All right, how about this one, friends? You're out skateboarding with your friends, and you're on this rail, and you're like grinding rails. Man, it's awesome. And then you're like, hey, guys, you got to record this with that GoPro. I'm going to prove these two triangles are congruent. And they're like, no way. And you're like, watch this. This is going to be the most edgy move you've ever seen. They're like, no one's done that. Tony Hawk can't even prove those triangles congruent. And you're like, I've got this. And they're like, all right, I'll tell your mom you love her if you die. And then you like go and prove the triangle's congruent. How? Reflexive property. That segment is congruent to itself. It looks like I've got an angle side angle, friends. Oh, angle side angle after using reflexive. Nailed it. Wow, man, guys, that was so exciting. Did you see that? I'm so glad we got it on film. Wow, I'm so pumped about this. All right, let's do this monitoring progress question. Yeah, it's labeled 1. Yeah, you got it. So it says, can the triangles be proven congruent with the information in the given diagram? Let's see. All right, I've got lots of parallelicity going on here. Not a word. Does anyone see anything that I can say is true? Right now, I know nothing about angles or sides. Yeah. All right, why is that? I like it. All right, because these two were parallel. All right, someone get another one for me. Angle what and what? What? Nope. 4 and 2. Okay. All right, angle 2, angle 4, and the y? All right, what else do we got? Jack. Y dubs is congruent to y dubs. Reason? Reflexive. And now the question is, are these triangles congruent and how? Actually, let's try to name these. X, Y, W maybe is congruent to who now? Z. Well, the Y's in the middle here. Y was this angle. This angle is congruent to this one, so I've got to go from Z to the dubs. Yeah. It's a rotation, not a reflection of these two triangles. So z dub y and y. No, there's some discrepancy. Which one is it? Y. Angle, side, angle, because the side is in the middle of the two angles. All right? So the S is in the middle of the two angles. Not necessarily. No, I don't know that. Like, because this could be like a weird parallelogram. Those aren't isosceles. Now that I have two angles by third angle theorem, I could prove those two are congruent to each other. Yeah. Not necessarily. Imagine this was more exaggerated, like this. All right. So that this is not congruent to that. Like, I don't know about those sides. So I don't know isoscelesness is basically where it's at. Let's see. All right, here we go. Write a proof. We got this. We are so good at these. We are so good at these. Okay, we got our gimmies. Give it. Give it to me. Wah. All right. Someone have something it's a fact they can give us. There's actually a lot. Yeah. Listen. To EBC. Yeah. And why is that? Vertical angles theorem. I don't know. I could see vertical angles theorem also being in the running for like best theorem, like most favorite theorem. I don't know. Given, I don't know. All right. So let's see. So I've got an angle, I've got a side. I need another angle. And actually, we've got two options. All right. Alternate interior angles theorem. I want to point out we also could have made a relationship between A and E for the same reason. The what? Alternate interior angles theorem. So I could have proven these were congruent first, and that would have changed my triangle congruence. The one that we currently have drawn is angle, side, angle. But if I showed this first, then I would have had angle, angle, side. So there's actually, this was like a choose your own adventure proof right here. So let's see, triangle ABD is congruent to triangle EBC. And the way we have up here is angle, side, angle. But in a parallel universe or something, you could have proven it slightly different, and that would have been fine. Let's see. Let me just jump right to example 3. Oh yeah, we're gonna get 2 more examples in today. I think we got it. We got it, friends. All right. Ooh. Really? That's it? Oh, maybe so. Maybe so. Actually, this one has a little bit more work than I might have thought. Let's see. So this might be the last one. Who knows? So let's see. Write a proof. H is parallel to GK. I'm just going to write the givens. All right. Everybody loves the givens. Okay. Angle F and angle K are right angles. Oh, it's one of these ones. That's why it's a little more work. All right. So those are right angles. I'm going to say, therefore, triangle HFG and triangle GKH are right triangles. Right, you guys agree? Why is that true? Def of right triangles. All right, right triangles are ones that have right angles in them. All right, okay. So let's see, we've got that. All right, we've got parallelness. Does someone else see something else that'll help us? Aiden. So GH FK and FGH are congruent. Yes. I couldn't have named these other ones. No. Wait, those are the ones I can't name because I don't know parallelness here. Oh, so yeah, we are limited. So it would have been this angle and this angle, which, yeah, means I gotta... All right, but we learned together. Oh, no. Oh, dear. GK... no. No, I don't have a good way to erase it. Because it would actually... Oh, yeah, that's fine. Nah, we don't have enough time. It's too dangerous. Eventually, we will. Once I know those triangles are congruent, then I'll be able to prove other things about those angles. And once I know those angles, then by the alternate interior angles converse, then I would know parallelness. But right now, like that's after I would have already proven the triangles congruent. Oh, no, those perpendiculars are opposite of each other. If they were both like this, yeah, we'd... Okay, all right, there might be a transitivity of perpendicular. Yeah, there might be a way to get that done. I see that. I see that. So let's see, let's name these correctly. FHG is congruent to angle KGH. And that's alternate interior angles theorem. And what else do I got? Yeah, Alyssa? Yeah. I think you guys are starting to like this. It's starting to work. These proofs, we're falling in love with them. Oh, yeah, we are. And so let's see. I think we have enough information to prove what we set out to. How do I prove it? Why are those congruent? Angle, angle, side. Yeah, angle, angle, non-included side. But wait a minute. Look at this, guys. Look at, I've got angle, side, angle, though, right? All right. But I do want to point out that notice angle, side, angle. These are not angles in the same triangle, so I can't use angle, side, angle there. I was trying to be sneaky. All right. Now, third angles theorem. Here, guys, we've still got 5 minutes, so slow down. 5 minutes. Let's just talk through this last one here. Vertical angles theorem, yeah. Angle, angle, side. Look how quick you guys are, right? $100 on the whole course. All right, I want to make sure you guys catch this. Look at this. These were all of the actors in our Congruence of Triangles chapter. Lots of good ones here. All of our favorites. Oh yeah. He would be a hypotenuse leg, I think. Like if I had to cast him as one of the triangle congruence theorems. Oh yeah, Danny DeVito, hypotenuse leg, all the way. Right. So this is a great little chart. I just wanted to make sure that that you guys realize you have this. This is a great resource when you're proving things about triangles, all on one page. All right. Thanks for watching, internet friends. Have a great day.